the top priority of today is that we will go ahead and look more into the stretches, whether it's vertical stretch or horizontal stretch. Okay, yesterday we did a lot of transformations, and one thing in particular is to make sure that you factor out anything that sits in front of x, and we will see those examples today. Now, so before we continue with the actual graphing, let's make our let's specify a few things first. In particular, I want to specify, or I want to make sure that everyone's on the same page about the A and the B. So, if A, okay, the equation right here, if A is bigger than 1, what does it mean? When A is bigger than 1, what does it mean? This A right here. First, which direction? Is it vertical or horizontal? It's vertical. Okay, again, the one that's way up front. Okay. Now, the better way to tell, okay, if you say, hey, Mr. Chan, I have a hard time telling which one is vertical, which one is horizontal. Now, we are talking about cubic function, right? So this is the cubic function. And let's settle this once and for all. If you were feeling some challenging moments in telling all these transformations, this is the cubic function. And anything that's happening within that cube, it's the horizontal changes. Anything that happens outside will directly deal with the y values, the vertical side of it. So the A value would be your vertical stretch or compression. And if it's bigger than 1, okay, if the absolute value of A is bigger than 1, then we say it's a vertical stretch by A, by the number A, okay? And if it is a number that's less than 1, like a 1/2, then we know it's a vertical compression by the factor of A. Okay, so you multiply it with that number. If it's 1/2, you multiply by the 1/2. Okay, so again, I also want to make sure that somebody made this mistake. Not a lot of people, but some still made these mistakes. That is, I want you to know that if it's bigger than 1, that's how we know it's a stretch. And if it's less than 1, then that's how we know it's a compression. Okay, getting smaller, right? Getting smaller, it's compression. But when we move on to B, it's a little bit different because it's no longer about the vertical. It's about the horizontal. And if you remember from last semester, everything is inside the parentheses about the horizontal things. It's like a bit weird. It's like always the opposite. Like if you look at x minus h, right? The minus here, okay, that's weird. If it's x minus 5, it's actually moving to the right 5 units. And what about the B? Well, if B is bigger than 1, then we say it is a horizontal compression or shrink. Horizontal compression by, if you remember, it's always a reciprocal, 1/B. And if it's less than 1, then it is a horizontal stretch by also 1/B. So now I'm going to give this example because it's a reciprocal and things might be a bit challenging. So for example, if B is equal to 1/2, okay, then it will be a horizontal stretch by 1/1/2, which is 2. Because the reciprocal of 1/2, it's 2. Okay. If it is if B is equal to 1/3, and then it's a horizontal stretch by 3. Right? So you want to make sure that you have some solid examples in your mind, okay, that can tell you that, oh yeah, I know what it is. If A is negative, it's a reflection over where? It's a vertical kind of reflection, so it's over the x-axis. Okay. So now, what does it look like? Okay, if it's a reflection over the x-axis. So yesterday we drew a bunch of cubic function. It looks like this, right? But after reflection, it becomes like this. Okay, so that's vertical reflection. Okay. If B is negative, then it is a reflection over y-axis because it's a horizontal kind of reflection. So a graph that was originally like this would now become like this. Anything that catches your attention? The same. It is the same. Okay. It is the same. So now, if you want to, if you are not comfortable with this surprising discovery, like, wait, what? They are the same? How? So, so here's how it works. Okay. Now think about this. Okay, think of this example. Right. So if we start from here, let's start from here, right? So what does the cube mean again? Like the actual meaning of cube is to multiply itself 3 times, right? So we say, well, okay, let's go ahead and actually multiply negative x 3 times. What is it going to be? And now you're like, oh, so this we will interpret as a reflection over the y-axis, right? But then over here, we'll interpret it as reflection over the x-axis. And can you see the equal sign right here? And that's how we prove. And that's how we say, oh, that's a reason why we say the reflection over the x-axis is the same thing as the reflection over the y-axis. So not too surprising. Okay. So and also, here's another thing I want you to annotate. Now, this is going to be more more frequently asked as you go to pre-cal next year. For a graph that looks like this, we call this an increasing function. Can you see from left to right, the graph is going up? Okay, can you see that? From left to right, the graph is going up. And after reflection, this function would go from increasing and becomes decreasing. Okay. This would be even more important as you move on to calculus. The same thing is true over there on the other side. It went from an increasing graph originally, and after reflection, it becomes a decreasing graph. Okay. All righty. So that's a little introduction for all these A and B values, and we'll focus on a lot more today. So let's go ahead and take a look at example number 1.